After performing an independent samples t-test, you should also be able to calculate effect size. Remember that effect size allows us to measure the magnitude of mean differences. Like for example, if a t-test tells us that two means are different, we can calculate effect size to see if they're just a little bit different or if they're very different. This is usually calculated after rejecting the null hypothesis in a statistical test, meaning the means are different. If the null hypothesis is not rejected, effect size doesn't really have any meaning. So here is some sample data that I've already run a t-test on. I have the mean, standard deviation, sample size, degrees of freedom, and t. It's already all there. So we're going to use this information to calculate effect size. So we're going to use, first of all, Cohen's d to find effect size. Cohen's d is just the difference of the two means divided by the square root of the pooled variance. So using this information that you would already have if you did a t-test, we can put those into the equation to find the effect size. And doing it just like that, we get a Cohen's d of 3.14. Well, what does that 3.14 actually mean? Well, there are certain criteria for Cohen's d. If your d is about 0.2, that means you have a small effect. If it's about 0.5, that means you have a medium effect. And if it's 0.8 or larger, that means you have a large effect. In this case, 3.14 is much larger than 0.8, so that indicates that we have a very large effects. Our means are likely to be very different from one another. Instead of just being a little bit different, they're probably very far apart. Now there's also another way of calculating effect size called r squared, and this is the equation for r squared. It's t squared divided by t squared plus the degrees of freedom. And if I were to do that using what we already know, I would find an r squared of 0.718. And this is just like Cohen's d. There are different criteria to measure the effect. If it's 0.01, that's a small effect. 0.09, that's a medium effect. And 0.25, that's a large effect. In this case, we had 0.718, which is a lot more than 0.25. So again, it would indicate a very large effect. Cohen's d and r should be relatively similar. R is really a measure of how much variance is shared between the conditions, and that's kind of an advanced topic, but just know that r squared is just like Cohen's d. It's a way of measuring effect size. And that is effect size for an independent samples t-test.